All right, welcome all. I thought I'd start out by telling you a bit of a story about some of the things that can go wrong in the world of DevSecOps and operations as we see it. This is a true story, about a month old, from CloudBees. Basically, all our engineering teams, we want to go faster. It's what we've heard all day. We want to go faster. No one's ever saying we want to, well, generally I'd hope no one's saying we want to go slower. But the downsides to that sometimes are they're going so fast that sometimes mistakes are made. So in this, well, it's not an example, this is real. The developers committed some credentials. We've heard it all before. You put some credentials into a private repository, no big deal. Unfortunately, it's on GitHub. All of our code's up on GitHub. It was a public repo, which is not ideal either. But you know, they noticed. That was great. They noticed that the credentials went into that public repo, and so they revoked them, and that was that. So we do the postmortem. They did that internally. They didn't reach out to InfoSec. We've got a separate team for that, a separate team for operations. But the questions that we ask and they ask afterwards is like, how did this happen? How did we end up in a case where we're committing credentials into public repos and pushing them up to production? And some of the reasons that we sort of come up with are difficult to pin down, but some of them aren't that difficult. Complex integrations, you've got things everywhere, all talking to each other, and they've all got credentials, and not everyone knows what all those credentials are for. They've issued them, someone's left, someone's come back in. And so, yeah, those complex integrations. CD and continuous delivery systems like Jenkins, or whatever you're using, they're the nexus for all the power in the system. They can deploy to production, they can read source repositories, they can usually write to source repositories as well. If your development environment isn't mature, you will have the ability to do things that it's just convenient. Everyone knows what it's like. You're setting up a new project, it's convenient. You don't have like a team of 6 people writing IAM policy for you to lock things down. And there's also the human factor. People make mistakes. And in this case, we've got people in our team who were responsible, Jenkins X team, and he knows this slide's in here. I won't name names. Yeah, so these are the kinds of things that can happen. So we'll go back to this story in a little bit and talk a bit more about what were the outcomes, because that's not the whole story. So what we've got is very much a case of we're trying to shift left, and we've heard of shift left for QA and things like that. Oh, we've got to do our testing earlier and earlier. And we've got the same thing occurring now with DevSecOps style challenges. So we're trying to push security and infrastructure back into the earlier stages of the environment delivery, because you've got teams that are now rolling out infrastructure. They might be terraforming it. So you've got a development team that's terraforming a production environment. So you can't just run InfoSec down at the end of the process. It doesn't make any sense. You've got to be running InfoSec from day one. And that can either occur from team members inside the team, or it can be externally, like pushed down by operations or by InfoSec. But I run mainly a pure operations team at the moment. We're shifting, and so I'm going to talk about the transition we've had over time. So when we started out, and this is not just us. We've gone and surveyed the market, and I think Stripe has basically said they evolved along a very similar kind of process. So developers are ops or InfoSec. Small team, everyone's doing everything. They're doing the best they can. You might have a few team members who are a bit more operationally minded, a few who are a bit more InfoSec minded, but in general, they don't have a dedicated role unless you're developing like specific software in an industry that requires that kind of thing. And then over time, yeah, you tend to get specializations with that team, and that's what we found too. Specializations towards DevOps, InfoSec. My role, I evolved from development into more operations style work. And then you end up with an operations group that's external. And we're not talking about best practices or capability, maturity, or anything like that. This is just the evolution that we see in quite a few teams. And you end up with a operations team, then basically they're on the outside and they're maybe putting team members into the development teams. So they, in our case, we put an operations team member into a development team and they help them for a few sprints, and then they might come back out and then they'll go into another team. And so we get this cross-pollination effect between the different teams. And then things start to get a bit more complex. You get more and more staff. I mean, Sasha said today, we've got 500 staff now, much bigger teams. And so we've got to the next level where we've got InfoSec as a department, but also InfoSec inside each development team. And so they're reporting on a regular basis back to their main InfoSec team, or the guild effectively, and it's the same with the operations teams. We've got operations sitting in each of the development teams doing operations style work. So the advantage of that is that you've got, you build it, you run it, you secure it, and if you don't, you own it. And then as you basically will face all of the challenges down at the development end of things, but you've also got that oversight. It's not so much oversight, but this the specialists in the main groups who are spending more time working out, well, if we're going to do this particular kind of scanning, we can do it across all the products. It doesn't make sense for each team to develop their own complete InfoSec capability. So that comes down from the top. So back to the story. We weren't quick enough. In the time that the credentials were out in the repository, which I think was about 3 hours, and this was a development environment, that's why it was never reported like externally, no customer data, nothing like that. It was just a pure development environment that had just been stood up, but it was in our main account. So the attackers launched some instances. If you've ever been running in the cloud, you know what that's like. You see a few instances pop up and you go, oh no, the bill's going to be starting to go up. So they launched instances to the limit of our account. And with Google, the way we've got it set up is that all of the projects live inside the one organisation. So yeah, our limits are reasonably high because we need limits across all the different environments. They launched it in every region, even regions we don't use, never going to use. They launched everywhere. We didn't have it locked down. It was a new development environment. So we're on an invoiced account, so there's no credit card limit on our account. 21,000 CPUs launched over the weekend. Yeah, happened on a Friday afternoon. Our main InfoSec and operations team we'd sort of checked out, and it wasn't alerted because it's a non-production system. We didn't have alerting on that one. We do now. $3,000 an hour over the weekend. We got a bill. I found out on Monday morning when I got a request from finance to approve a bill which was $70,000 higher for our Google. So there was a lot of stress in that development team. We dropped the ball in operations because we'd let them run off without all the guardrails and things like that they needed to help them do the right thing. And by the same token, they'd made some mistakes, but we'd made some mistakes too. So yeah, as I said, Friday afternoon, and we noticed on Monday. And yep, it was very much show me the money from the Google account team. So the Postmortem, once you get executive level attention for a $70,000 bill, yeah, root cause, development environments are in Google Cloud, it's development, and it was less mature for us. We were predominantly AWS, all our production environments are in AWS, so we've got IAM controls around everything, not in Google. It's a lot simpler. So some of the things that we talked about in the postmortem were putting up more guardrails around the developers to help them, and so they're part of that process. Trying to limit the blast radius. Like, why did we have so many regions activated? We don't work in that many regions. We do maybe 2 regions in the US and 1 or 2 in Europe for most of our work. The processes, a lot of this would have been avoided if we'd managed to get the developers to engage with InfoSec and operations. They thought they had it covered, but they didn't. But as soon as there was a breach, part of the reporting policy, the incident reporting policy, is to contact us. But they didn't know about the policy. We know about the policy, but they don't know necessarily about the policy. So it's about that communication. So I'll do a survey. Who here hasn't had a like a breach of a development environment, or not a lot of hands go up. So they're either you don't want to sort of put a target on your back, or yeah. I think most people have had a case where they've put credentials somewhere they shouldn't, and they've managed to get rid of them before anyone's noticed. But these days, the window to exposure on checking something into GitHub is very, very small. GitHub notifies Amazon and Google that you've checked something in if they detect that string in your code, and they've got regexes and things that they run. And if you're writing like a service, then you can contact them and get them to add like triggers to notify you when people, or notify people when their code gets checked in. So more than half of US businesses have experienced a cyber attack, and that's in the last year, which is a pretty sobering statistic. And we're hoping it's probably not the same, 53%, but I've a suspicion that there's a reoccurrence rate that's quite high. So when you're trying to develop your environment and work out how things are going to be traded off, because it's all about trade-offs. You don't have infinite staff, and even if you did, it's probably not going to help that much. There'd be infinite communication to go with it. So trying to work out, it's all the standard things that you've got with DevOps, which is smaller, more frequent change. But you also need to bring with that more automation around your security. You can't have like a 6-monthly audit by InfoSec if the developers are making infrastructure changes every day, because you'll be straight out of SOC 2 compliance, which requires you to like have a plan for infrastructure changes. So you've got to build that in from the start. With your infrastructure as code and your developers making those changes, you need to start to put guardrails around them. So as an operations group, or even if you're part of your development team, think about what kinds of guardrails that you can put around maybe how many compute instances they can launch. Did we need to be able to launch 21,000 compute? No, probably not. But we know we can now. We can do a nice big load test without any issues. Also, like the IAM credentials that were being used, they were too broad. In this case, we needed the admin to launch instances. That's part of what we were doing. But we've often seen, we'll just use admin credentials, because you know that that's going to work. It's also going to work for the attacker to go and do other stuff. A great example we had is we had a developer on AWS checked in their credentials, deleted them, and then we noticed that we got a spike on one of our logging metrics. And we go, wonder why that's spiking up. And it was because they were trying to launch instances over in the AWS account. But on AWS, we've got a much more restricted environment. So you log into one account and then you assume rollout to another account. You've got to have MFA set up to do that. The attacker didn't have MFA, so they're sitting there trying to launch instances in an account they can't launch. So it was exactly the same failure. But on AWS, it was like, oh, look, that's interesting. And on GCP, it was a $70,000 mistake. So, yeah, as you put more administrators into an environment, necessarily there's more places that things can go wrong. So we see it with everything. I mean, we've got lots of Jira admins because they need to modify policy and things like that. And every week it's, who made that change to the policy? Where did all my statuses go? Things like that. So restricting on the DevOps side is the same kind of thing. You don't need to give all of your engineers ability to push changes to a production environment. There might be 2 or 3 of them who have like full access because they're trusted. You've seen them operate. They think things through. They're a bit more senior and they just think in that manner. So defining policy organisationally also goes along with the defining it at a code level. And as you've got more systems, more surface area, more pen testing, and I'll discuss a bit later how we, some of the ways that we've found to be quite valuable from that perspective. So, blast radius, we can limit the damage and impact to customer data. So if they've only got access to a development environment, which tends to be the ones that get breached first, if you can limit the blast radius and that escalation of privileges across your accounts, you're in good stead. So, all those different environments are segregated. So, don't run your production workload in the same environment as your staging workload, even if your developers are saying, oh, no, they're great, they're multi-tenant, we can do that. That's true, but you often find that people don't treat data in a staging environment or a development environment with quite the same standoffishness as they do for production. It's also a morale thing. No one likes getting their software broken. No one does. I mean, I take it very personally when we discover something that's been left open or someone's made a change that we didn't notice, whether it's from within my team or we've got an embedded operator out in another team who's discovering things, and then I've got to report that back. So it's good for morale to have all these processes and make the developers go, I've made a mistake, but I know what the processes are to rectify it, and I'm not going to get slapped really hard for making a mistake. So the developer in question still works for CloudBees. There was no question, but he felt bad for that week. And so, the velocity of the team definitely gets impacted with a security breach. Everything slows down. You go back and there's more management meetings and things like that. So I've talked through these slides. So stop those catastrophic failures, etc. And we were talking about the incident reporting process. Part of SOC 2, which we're going through at the moment, is to basically you've got to document your processes and then make sure they're enforced. And so, if the development teams don't know about your incident reporting process, they can't follow it. And just because it was in a line item that they needed to read the InfoSec policy at the start of their employment 6 years ago, they're not going to go back and read that. Things change. So that sort of drumbeat of communication and postmortems going out to engineering is an important part of the process. And it increases the value across the board. Like if you're out talking to developers, you'll find out stuff anecdotally. So my fundamental observations about the development teams that we work with, and that's development, support teams, QA teams, productivity teams. They're all doing development. Business development is often they've got Git repos, they've got Nexus repositories that they're using. And so in any development team, you've always got the generalists and the specialists. Generalists from the perspective of operations or InfoSec or pure engineering. And then you've also got the generalist who's sort of good at everything. They might be just able to do a lot of different things. So you need to cultivate that. That's what we've found, is that cultivation of those different roles is important. Give them more, give the specialist, if someone's good at ops, give them more powers in that team. So, and we also classify people into the stabilizers and the volatiles. The volatiles are the people who go out and they make the big, broad-ranging changes. And And sometimes, like I'm more of a stabilizer personality, and you see them and you go, why did you do that? Why did you turn that on in every environment without like testing it? And why did you do it on a Friday? But you know, a lot of the time it works and they get stuff done until they don't, until they break things and things don't work quite right. So it's important to have both types of people in your teams. The volatiles, they're fantastic for certain types of tasks. But then you also need the boring stabilizers who like writing process documentation and love Jira and all of that kind of stuff. They're an important part. So, yeah. So we run these cross-functional teams now. That's where we're getting to. So a lot of the time we're just basically trying to get to the strengths of every specific team, whether they're InfoSec and they're good at finding bugs. I don't know what it is about the kind of mentality, but you can definitely see certain kinds of developers have got the knack for like looking at code and going, oh, there's like 6 edge cases in there that you haven't considered, and oh yeah, there's this system over here, and when we pass the header from over here to over here, there's going to be another problem, and those are the ones that we sort of look at and go, oh, these are the great kind of InfoSec kind of people. Not that they would love necessarily process, but they've got this brain that can find issues. So yeah, you want to cultivate those kind of people because they're good for testing and good for like finding these like subtle bugs. There was one yesterday reading about how they had 2 content length headers in a HTTP packet, and you can use that to get through certain firewalls and confuse the second layer. And it's just like a general engineer doesn't necessarily think like that, and then this person's like spent weeks working out how to use that as an exploit. It's a sort of a fascinating process. So yeah, making it secure, being sneaky. Like I use sneaky in a nice term there. And then you've got the operations mindset, which is we want to keep it running. We want to prevent single points of failure. I can't imagine why. You don't get woken up if half of a cluster fails. Well, you might. That's probably not a good example, but you don't get woken up like if half the cluster fails and you're going to be around in an hour, then you might have a little bit of leeway. So I'll give you some specific examples. Bug bounty programs. If you don't have one and you're a reasonably like large organisation, I was shocked at how effective it was. We turned it on. We use HackerOne, and we switched them on at the beginning of the year, and they found a lot of stuff. Some of it very boring. Oh, there's no API limit, rate limit on certain things. Okay, yes, that's correct. We're getting rid of that system. There's not actually anything you can do with that. But they found some really good stuff that we wouldn't have discovered, like subtle ways of approaching problems with APIs that they could then use to find other problems in other parts of the system. So I will caution, when you switch it on, they are super excited. We had like a huge number of reports in the first week from the bug bounty program. I think we had like 4 or 5 hackers invited to the program. It was all very professional. Like you get like big long traces of what they did and how they exploited certain things. But yeah, they know that a new company coming onto a bug bounty program, there's low-hanging fruit on there that no one else has been paid for. They might already know about it. They're waiting for that bug bounty program, and they'll hit you. So yeah, the first week there's a lot of payouts, and the other thing is that they'll do crazy things that you won't expect. Like they're basically, there's a webhook notification endpoint that you can add notifications to. Oh yeah, so they worked out that there was no limit on the number that you could use there, and so they used that to do a port scan of an internal system by creating 20,000 webhooks, which overflowed the queue that was waiting for webhooks to finish. And it's just stuff like that. Like it breaks real stuff. They're not trying to, they're just doing what they do. And the other thing that we found was that it's important to make the engineers part of the process. Engineers, software engineers of all kinds don't want to, like I said before, they don't want to find out that their software's broken. And they especially don't like it when you've got InfoSec coming to them going, this is broken, it's been bug bountied, because then they take it out on InfoSec. Whereas if you involve them in that bug bounty process, they can take out that frustration on the hacker. But you know, the hackers are actually on your side. They're not going to. Well, I'm hoping they're not going to take customer data, but it's better than the hacker that's out in the wilderness that you don't know anything about. Another of our key takeaways for the DevSecOps and Shift Left was about IAM. So in AWS, there's a very mature system of identity and access management. The best practices now are you have all your users logging into one account, and then you can assume role, no static credentials. So if you're launching workload in Kubernetes or in ECS or instances, you use that to issue credentials on the fly. That's been a huge help for us. Static credentials, they get checked in. Like I said, ephemeral credentials, you can check them in, but you know they're gone in an hour. So the window of exposure is quite low there, and most developers don't, because you're not passing them the ephemeral credentials to do something with. They're getting them from an API. They don't even generally see them. So it's quite useful that way. We've had a lot fewer issues with ephemeral credentials. Make production special. So like from our point of view, production is a separate account. Don't run your workload altogether. There's no need to anymore. Amazon support for multiple accounts is quite good now. It's still a hassle setting up new accounts. I won't deny that, even with that vending machine thing that they keep pushing, but it's still a bit flaky. So yeah, create production accounts, create staging, create development, and if the developers need different roles in each one, give them the different roles. They don't need necessarily the same thing, and then you can issue your IAM down to the machines and service accounts that can be different to what the developers have got as well. So you can really restrict it down, and yeah, put a lot of tooling around that as well. There's a heap of stuff now on GitHub in terms of assuming role. Most things now assume role. Jenkins assumes role quite well, so you can avoid having those static credentials. That was because we just refused to let them, the Jenkins engineers, put static credentials in. So they were forced to use to write that code for us. And then you've got your auditoring and your monitoring and alerting. Like I said, for our horror story, we dropped the ball. We didn't have a lot of monitoring and alerting over in the development environments because it's hard to monitor developers. Like, especially, this was a Jenkins X project, and like they were spinning up like a huge amount of workload, then tearing it down, and it looks like you're being hacked every day. But so it can be difficult at times. But definitely looking at the bills on a more regular basis, having budget alerting will give you an idea, because a lot of hackers are very basic. They're just launching Bitcoin mining stuff. They don't even, from what I could see in the logs, they don't even look at what they're doing. They just hit the button. Oh, I've got some credentials. Hit the button and then try and launch things. And so that's you need that layered approach. Notify the right people. Make sure that your accounts are set up properly with notification addresses. Like we should have got a notification from Google on our InfoSec group, but we got it on the development group, which doesn't work on the weekend. Operations in InfoSec don't work on the weekend unless we have to, or we get an email like that. And also say audit the inviolates. So we audit for new defects and use third-party tools. So the inviolates for us, these are things that are part of the best practices that you'll see. If you go out and look, a lot of there's like scanning tools now. There was a thing at, there's a hacker, I don't think it was DEF CON, there was a hacker conference last week, and the new thing is to go and look for public EBS volumes. It's like, public EBS snapshots. You have to go through and you have to click to make it public, but yeah, people do that. And so they just scan through and then they mount them all. They said there's heaps of data out there. And so you want to do auditing in your accounts for that. Check down all your security groups, have a VPN. It's a lot harder nowadays than it was in the past to control a development group. In the past, well, they were inside the data center. You controlled the firewall. There was no getting out. But now they're running on the internet and they've got admin access and they can open the security groups because it's easy and they're on their laptop at the coffee shop. And so if it's easy, they'll do it. So make the good things easy. Put the VPN in place, make it easy. Audit the security groups and report back to them going, you've opened this security group again, like we've got a VPN, use that, and then it'll be easy. You won't have to talk to me, which is high on everyone's list. Avoid IAM users. Well, we avoid them in our accounts by having a service control policy at the top that says you can't create an IAM user. So that's the blunt force approach to controlling things. They generally don't need it. I think we've got about 5 IAM users outside of our login account for various legacy applications. And so, yeah, using service control policies to do that, which they run at the organisation level in AWS. We also want to audit for new capabilities and new best practices. So that's thing, like I said, the EBS snapshots. So you've got to, that's the advantage of having an InfoSec group. They're maybe looking at, like they've got a different focus. They're on the security lists and they're monitoring things a bit more closely. They might see some new things come out a bit more reliably. But if you're using a third-party tool like AWS Advisor, and there's a bunch of new auditing tools when I went and did a survey a few weeks ago. Basically, that replicate a lot of what we built internally. Yeah, the good thing about that is that then you get these new checks and you get new alerts. You get it, Monday morning comes in and you discover some new hacks come out and find out ways of detecting it. So they're also good for the unknown unknowns. And each tool is different. It's got different biases and focuses. Some things are focusing on AWS and some are focusing on container security. But there are a couple of examples of tools there. Qualys for your SSL checking and security headers. They're very basic. But there's a bunch of things that we get on our HackerOne reports that are picked up by security headers, which are like to avoid clickjacking and CSRF and things like that. So. There's open source tools and yeah, bug bounty. I'll reiterate it. Like it's horrible, but it's great. So it's horrible to receive the report, but you know what? I'd rather receive that report than the one that goes to Twitter or Hacker News going, look at these clowns, they did this. And yeah, we've dodged some bullets there, so it's been good. I talked about this earlier, embedding ops. So that's where we do rotations from the team. So if you've got a central ops team, maybe as a legacy, and most places are going to, like a larger organisation, you're going to have like a central capability as well as in the teams because there's global infrastructure, there's common infrastructure that needs to run. So yeah, we rotate team members out so they get to see what's going on in the teams, not as a big brother kind of thing, but more like, oh, they're doing this, and oh, they're doing this fantastic thing over in this team, and this team over here needs to see it. And so it's this cross-pollination between the teams, which we don't necessarily see amongst engineers who've got their head down working on product. So we find it increases the velocity. It's a free engineer for the other teams. We just go, right, we're going to give you an engineer for 4 weeks, and they're fully allocated to your project. Tell them what to do. And then we've got sort of guidelines of what kinds of work that we want them to do, but it's up to them. And then, yeah, we take that capability back. So if they discover that there's something missing, that the teams are doing something a bit silly or they could be going faster, then we take that back and bring that back into our core capabilities and then roll that out across all the teams. I would also caution in these talks today that don't believe everything you hear. Not this talk, of course. I believe everything you hear. But we implemented this tool and everything was wonderful. I think we've all heard that from a vendor. We don't have any problems and everything is secure. And we implemented this process and didn't run into any issues. It's probably the one that I see like most frequently. We go to these vendor talks and you sit through it and you go, oh, yeah, that's great, but we did a demo of that and it couldn't do that particular thing. And you go and talk to them afterwards and it's like, yeah, that doesn't really work yet. It's a bit vaporware. So yeah, I would caution. And the reason that I caution about that is that if you come to a talk and you feel inadequate, as like I sometimes do when I walk into these talks, oh, geez, these guys are really nailing it. I always remember this. It's like, it's not all true. There's stories being told here that aren't true. So it's just, yeah. You can only do what you can do. If you've got a team of one person, you can only do so much. So do the things that'll add the most value is probably what I'm getting at there. So the final, the slide of the recommendations, bug bounty, I think I've said that 3 times now. Automated auditing, you've got to automate. You automate your dev and your ops, you've got to automate your auditing and your operations, and we've got 70 plus Amazon accounts now. I can't audit that. I can't go and check 70 accounts. Like I had to go and change the tax settings last week and had to log into many accounts, and that was horrible. But to do that on a daily basis would be insane. So you've got to automate. With IAM in AWS, you can give your auditor just the permissions it needs. You can all be secure. You can run it all through Jenkins or whatever your automation tool is and do that. You can extend your automation tools as you find new things, which might be specific to your environment. Team rotations are critical as well. In my opinion, we'll see. We're just rolling them out. We've had about half a dozen team rotations so far. We've had team members go and work with our release team and productivity teams to speed up their processes and not so much speed it up, but work very closely with them to solve issues with their deployments that they've been putting up with. And I tell them I want to see that deployment done in less than an hour. And I said I don't care how many instances you have to spin up. So we give them broad-ranging kind of objectives like that to get in there and do ops stuff that maybe that team doesn't have as much ops experience, doesn't have as much Amazon experience. And I don't know why they're in a different order. But engineering buy-in, get your engineers to buy into the process, and I think that's the idea behind DevOps as well. So yeah, the questions. I'm happy to take questions from the floor, but usually I find it's good to kick things off. Did we get a refund on Google? Yes, we did get a refund from Google. So that was a happy day for the engineering question. He said he hadn't been able to sleep all week, worried about that $72,000 bill. So that's like one of the I think you have to ask though. Amazon's a bit pickier. We had a case where a contractor came in and ran a Lambda, and it wasn't even a breach. It was just a Lambda, and it recursed, and we had 400 million executions in a day, and yeah, it was like it was only a $3,000 bill, and we want you to shut down the account that ran it, and it's like that's a production account. We can't shut that down. So. Yeah, whereas Google just went, oh yeah, you're clearly stupid, and it was over the weekend. I don't think they would have been using it for anything anyway. So the biggest challenge, onboarding teams, I really struggle with from an ops perspective. We don't have a lot of turnover in cloud-based operations. I think we've had we've got new staff, but onboarding them and getting them up to speed is tough, especially because we've got fairly coarse-grained access at a global operations level. You've either got nothing or you've got a lot of access, and so that's not great for new starters. So we're trying to as we onboard more people, we're doing that more often, and so we're getting more granular levels of control, guardrails around ops effectively. And did I lie to you? No, I don't think I did. I was pretty truthful. Any questions? Yep. So the question was, as part of Shift Left, what other products and recommendations in terms of security analysis and like there's Sonar and things like that that do a static analysis. There's a couple of vendors out there like White Source and things like that. They do container scanning. The important thing with a lot of these scanners is they pick up a lot of noise when they're scanning, and so you don't want to, if you overwhelm engineering teams with noise, they get very frustrated very quickly. We all do. I just want to know what's broken. I don't care about. There's 400 packages in my container because someone's put it into the base container. I don't call them, so they're not actually a vulnerability in this specific use case. So you need to be able to whitelist things. Obviously, there's technical ways around that using scratch containers and things like that. But yeah, you need to be able to whitelist issues. But yeah, so in terms of like specific things that I would see for some of the security scanning, yeah, it's the static stuff is probably the easiest. We do also do we run a product. I think it's Arachne across our sites. So as sites get deployed out to the integration environments, staging environments, those products are being scanned like by the various scanning tools that we've got. So it's not directly integrated into the pipeline as such, but it's on an automated basis over time. I think there's ways of doing a webhook trigger, but it's very new for us to be doing that. So. Yep. Yep. Yeah, it's HackerOne. Yeah, it's the big one. Yeah, yeah, HackerOne. It was a good process, but yeah, the biggest issue I had is that I didn't expect the hit that we got in the first week, and that was not communicated to me clearly. They probably knew, but. Because I'm almost positive that it happens to every customer that goes on there, because the hackers get invited and there's lots of easy stuff that they can make decent money out of. So the thing I would caution, or not caution, but make sure you've got, so you need budget for for actually taking on HackerOne, and then you also need budget for the bug bounties it's surprising. It's usually, well, from what we've seen and what the vendor told us, you start off with a fairly high amount of bug bounty payouts, and then it drops off, and then you get the occasional good one that they find from there. Anything else? Well, thanks for coming along. I hope you've gained what you were looking for here. If you want to come and speak to me, I think, if we go back to the first slide, I'm Ben Walding on, goodness me, that's a bit slow. Yeah, so I'm at Ben Walding on Twitter. Don't believe anything that you read on my Twitter, but if you wanted to message me, that's fine, or I'm wandering around the CloudBees booth as well.